Ladies and gentlemen, we have with us Kratika and Akash. Please put your hands together and welcome them. They're going to be talking to us about recommending repeat purchases using product segment statistics. Over to you guys.
Uh, yeah. Hi everyone. Yeah. So those of you who were in the same auditorium, you just heard a talk about how Flipkart optimizes its delivery by improving the accuracy of our geolocation. So in this talk, we'll move to the other side where customer comes to Flipkart and we have to recommend him or her certain products and how we go about recommending that. And specifically, we'll be covering on recommending repeat purchases using product segment statistics. So as she mentioned, I am Akash, she is Kratika, and we work with the recommendations team at Flipkart. Yeah, so this is a joint work along with IIT Kharagpur, and this was also presented in this year's Rexis conference. So we'll get started. So to start with, what is a repeat purchase? So as you might know, repeat purchase is a phenomenon where a customer comes to Flipkart and we may, Flipkart or any other offline or online commerce portal where we may want to recommend the same products which he has already purchased before. So for example, you might be doing some frequent recharges where you placed you recharge your phone with a certain amount and then again after a certain month or next quarter you will want to recharge with the exact same amount. Similarly, you might be purchasing weekly or fortnightly groceries where you purchased some grocery items and again you want to purchase groceries. So we'll take in the next few slides, we'll take few examples from the industry where this repeat purchase has been applied. Yeah, so this is a screenshot from a local grocery website called Big Basket. What they do is they show me a widget which calling my smart basket. So these are products from my last purchases. So these three products have been chosen by Big Basket, assuming that I would have run out of stock on these products and I might want to refill my stock. So such a purchase will improve the user experience because I don't need to search for it. It's a direct reminder in the front of the website where I can directly add to cart and proceed to checkout. Moving to this example. So this is a Amazon Dash button. So what it basically does, it's a small piece of hardware, quite innovative I must say, from Amazon where they have introduced these slide buttons. So you must be seeing these three buttons. There is an Arial button, there is an Olay button and Gillette buttons which are placed in your wardrobe. So what purpose they intend to serve. So once you run out of stock on any of these products, say you are out of your stock for your Ariel or Gillette or your soap, you can just press this button and an order will be placed automatically on your account in Amazon. You will be charged and the product will be delivered in the next few days. So this is one of the things where repeat purchases comes into picture and Amazon has tried to integrate online with offline in this scenario. This is a screenshot from YouTube where it's not exactly a repeat purchase but kind of a repeat consumption. So there are some videos which I have seen previously and YouTube is recommending me these videos to watch again after a certain time interval. So this is another kind of repeat consumption pattern where you see on different offline and online scenarios. So now Kratika will take you through how we can apply such a repeat purchase construct in context of Flipkart.
Thank you, Akash. We have seen different examples from different domains where repeat purchase or repeat consumption pattern exists. Now we'll see how we can apply it to Flipkart context. So what do we have at Flipkart? We have millions of users in thousands of categories and people do make multiple purchases from same category again and again. So what can we do out of this data? We can actually figure out the such purchases which are placed again and figure out the repeat purchase pattern of every user and can recommend to user, can tell him, okay, now it's time for you to refill your stock even before the user realizes it. So this will increase the user satisfaction as well as the user engagement with Flipkart. So how are we approaching this problem at Flipkart? First, we have divided it to two sub-problems. First, because we have thousands of categories, we want to identify those categories which actually have such kind of patterns. And when we have those categories, we'll go and figure out what is the repurchase pattern of user in that category. So if you see that there are multiple categories, and when we analyze the purchase pattern of different categories, we figured out that repeat purchases are not very frequent in all the categories. There are categories where we don't perform repeat purchases. For example, electronics. So we don't purchase an electronic device again and again. If we do, it is either for our family members, or we want to give to our friends, or there are resellers who are doing repeat purchases because we don't allow multiple quantity of one product in one order. So they place multiple orders of same unit and they sell it offline. So when we analyze the data, we figured out that there are FMCG categories where these patterns are very prominent. So we have taken 5 such FMCG categories. You can see that there are soap, diaper, deodorant, wipes, and shampoo. So these are the categories these products we use on daily basis, and either we order them offline or online periodically. So in these categories, such patterns are very frequent. So, but we can say that the repeat purchases, it's different for different categories. For example, I might be using shampoo twice in a week, but bathing soap I'll use daily. So the purchase interval for each category will be different. So here we have shown the repeat frequency distribution of repeat purchase frequency for 2 categories. These are FMCG categories. So in the first category, if we ignore the first spike, you can see that there are users who are actually making the repeat purchase after 40 or 50 days, while in the second case, the users are making the purchase after around 20 to 30 days. So you can say that the data also says that the purchase interval is different for different categories. Also that this interval is independent of categories. What do I mean by that? My frequency of buying soap, it will not affect the frequency of buying shampoo. So we can assume that these phenomena is independent of the category, and we can focus on one category at a time so that we can do the learning on category specific. So we'll be learning the category specific model. So now we have explained our first subproblem. We'll come to the second subproblem, which is to figure out the user's repeat purchase pattern. So here in this diagram, we are showing the purchase pattern of user X in a category, let's say DO. So user has made the m-1 number of purchases in past in that category. So suppose that m-1th purchase was made at timestamp y. So what do we want to predict? We want to get the likelihood of the user purchasing the product M after a time interval of delta t. So on what factors this probability can depend? Consider an example of deodorant, and suppose you have made m number of purchases in the deodorant category. So whether you want to buy a deodorant now or not, it will depend upon multiple factors, like when you made the purchase last, when the Y happened, and what is the frequency of a user purchasing the deodorant again and again. There are other features also, like the quantity. How much quantity of it you placed in last. Suppose you ordered 2 deodorants. So there is a chance that you won't like to order it again because you already have the stock. But if any offer is going on, in that case you might want to buy it because you're getting it for low value, you can stock it for future. So all these factors will be the input to our model, and we'll try to get the output where we can figure out what is the probability of user making the purchase in some time interval. So here we have listed our input features and what output we want out of it. So input features will be like users' past purchases, as we discussed, because we are figuring out the repeat purchase pattern, so we need to have the users' purchase data. There are product features also which can affect it. So a niche brand can have maybe a lower purchase interval, whereas if the products of high price segment may have the higher purchase interval. Similarly, as we discussed, there are other features like offer, quantity, which affects it. So if an offer is there, it can elongate your purchase interval. Sorry, it can shorten your purchase interval, while the multiple quantities can shorten your interval. Seasonality also affects your repeat purchases. For example, like moisturizer, people do uses more in winter season than the summer. So these all will be the input features to our model, and the output we want is that our model should be able to predict the likelihood of repeat purchase as a function of time. So what do I mean by it? So in the next slide we'll explain that. So here we have explained our problem, we are formalizing it more mathematically. So we want to predict the joint probability of a product which can be purchased in a time interval of y to y plus delta t. What is y, as we discussed, is the timestamp of last purchase. So if we apply the Bayes theorem on it, it can be broken down to two terms. First is the conditional probability of user making the conditional probability that the user has made the purchase of that product. What was the probability that it was purchased in interval of delta t? And second term, B term, is the independent probability of user making the purchase. So in second term, we are just checking the interest of a user in a product. So it can be actually estimated from the traditional recommender system that we already have. And the first term has the time. So now our motive will be to estimate the first term. So first term has this time term. So if we estimate it, we would be able to recommend the right product at right time to user. So how can we evaluate this second term? So we are using this conditional opportunity model. So this model it is modeled by leveraging Weibull distribution with all the input features that we mentioned. And then feature weights we are learning by applying EM, expectation maximization, over it. I'm not going into the details of model, but will illustrate its application with an example. So now we have the probability of each product. So these products are sampled from users' past purchase history. So we'll get the probability of each of the products purchased in past, and when these values are above a threshold, at that time we can say, okay, this is the time that user is most likely to purchase this product. We'll explain this with the example in next slide. So this is a toy example. This is the graph for one user, which shows the probability distribution of user making a repeat purchase with some time interval. So if you see, there are two graphs. One is the blue graph, which is for category diaper, and there is a red graph, which is for different category deodorant. So here, bold dots represents the user's actual purchase, and there is a dotted line which shows our threshold value. So whenever our probability value is above this threshold value, at that time we will recommend that product to user. So considering the red graph here, user made the purchase at around 25th day. After that time, we computed the probability of all the products purchased by that user in past. And so since it's follow a Weibull distribution, that probability, this graph is showing that distribution, and it will increase to 1. So when this probability will cross this threshold value, at that time we'll say, okay, now is the time that user is most likely to make this purchase. At that time we'll recommend it, and when the user has made the purchase, it will again drop to 0, and from there onwards, then again the same thing will happen. So in this model, we are learning the model for every user and for specific products, only those products which user has purchased in past. So we have some limitations for this model. It requires multiple past purchases. So if there is a user who has made only one purchase, for those users we won't be able to recommend anything. The second limitation is that because we are recommending only the past purchase products, so there are high chances that those products can go out of stock, and we'll lose the opportunity to recommend to those users. And there is no way to surface the diverse content. We are only recommending those products which he has already bought. So we are not providing discoverability of other products. So we wanted to do better. So Akash will explain you the another approach that we applied to overcome all these limitations. Over to you.
Thank you. Yeah, so as Kratika mentioned, so there are certain limitations with this model. We need to exactly predict the same product for the same user. So the way forward, we'll describe a model that we applied next, which tries to generalize rather than focusing on an individual user and an individual product. Okay, so what do I mean by generalization? So both in user and product space, we can generalize to a higher level. For example, for a user, there are various segments of users. So there is, you can segment it users by gender. So there are male users and female users. Then by location. So there can be users who are living in metro cities and tier 2 cities. So for these segments of users, typically the repeat purchase pattern will vary differently. Similarly, for products, we can model it at a higher level. So we mentioned something called a product segment, where instead of drawing inferences at the exact product level, we'll draw the segment of the product and then try to predict the accuracy within the segment instead of recommending individual products. So for this, if you consider this screenshot here, this is two users, blue user representing an active user and a red user representing a dormant user. So across 4 time periods, the blue user has more purchase activity than the red user. So what such a thing tells us is it gives a useful information that blue user inherently has a bias towards more purchases. He is more active with Flipkart, and hence while predicting, we might want to use the previous purchases as a feature to over the dormant buyer. Similarly, there can be other kind of segments, like metro users might be doing more shopping online. So when they do online shopping more, their likelihood of purchase increases. In the product space, on your left you see Tresemme shampoos, which are typically priced very high, and on your right you see Head and Shoulders, which are lower priced, in the lower price bucket. So here also the choice of the segment will dictate your repeat purchase. So if you purchase Tresemme, you might want to wait longer. On the other hand, Head and Shoulders, the pattern might say that people purchase more frequently. So we want to use these user and product segment in our modeling. Okay, so in our modeling, we use a 2-tiered prediction. So in the first tier, there is a sample user where we want to predict the vector of, so this vector represents the category which a user is likely to purchase. So here, what we have fixed it. So we have fixed the user, we have fixed the category, and the time interval. So say within the next month, we want to predict whether the user will purchase how many diapers, how many shampoos, and how many deodorants. So in this case, say our model is able to predict 6, 8, and 3 respectively. Now, given that we have know that user is going to purchase 8 shampoos, we want to go dig deeper and find out which segment of products that the user is likely to purchase. So in this, you see different segments of shampoos. So first one is a Khadi shampoo, second one are Dove, and towards the last it's Head and Shoulders. So what we want to know is, we want to get to a specific product segment based on the probability which is given by our model and within the category. So in the next slides, we'll cover how we make the prediction in tier 1 and tier 2, and we'll discuss how our model performs against the baselines. So first, the baseline for tier 1. So here, as I said, we want to predict the number of diapers which you will purchase in the next time interval. So a baseline which we took for this is mean number of purchases from the past data. So we took past k time windows and just take a mean of that and showed it to the user. So that forms the baseline. So what does our model actually do? So basically, the repeat purchases of the number of repeat purchases of each customer are independent, and they follow a Poisson distribution. So independent across different time intervals, and the mean of the Poisson distribution is sampled from the gamma prior phi. So we'll not go into the exact equation of this. We'll illustrate the result. So I'll mention how we can read this graph. So light blue is our standard deviation between the prediction based on the baseline, which is mean, and the test data. So as you see, the standard deviation is higher for the light blue cases for all the 4 categories. On the other hand, the model prediction is closer to the test data, and this is shown by in all the categories. The darker graph is lesser standard deviation than the lighter graph. So that's how we know that the model that we use, the number of repeat purchases we are able to predict in a better way than just applying a plain mean over past purchases. Yeah. So now we'll move to tier 2. So for taking a baseline of tier 2, we take the top selling product segment within a shampoo. So suppose we have chosen that we have our first model has predicted that user will purchase in the next time window 8 shampoos. Within that, we want to say the top selling. So say these are arranged by the selling thing, the sales. So in this case, we'll just recommend blindly that user will purchase Khadi shampoo next. So this will form a baseline for the next, for this tier 2 prediction. Yeah. So in this case, we assume that each customer's choice within these product segments. So given a shampoo, we have a set of product segment, and each customer's choice will follow multinomial distribution. So we have to divide the number 8, which is the shampoo, into different categorical segments, which are formed by different brands or different price ranges of those shampoos. The choice probabilities itself are biased, and they follow a Dirichlet distribution across different customers. And the priors and the choice probabilities are estimated using, again, EM step. And since this is learned per category, we could easily divide our data into various, category-specific data, so that because the one category is purchased, we are assuming that they are independent of other categories. Yeah. So now we'll come to the evaluation of the second tier. So in the second tier, we wanted to predict the against the top selling product segment, how well do we do, instead of recommending the most popular one. So here, the metric that we use is conversion rate. So what conversion rate is indicative is how often does the model prediction lend up to a purchase. So here, our model is represented in light blue, and the baseline, which is giving the top product segment, is in the dark blue. So here, we see that our model performs better than the baseline, where we just recommend blindly the most popular segment for the category. So these are the graphs. Yeah. So finally, we want to say how we want to recommend it to the user. So there are multiple channels through which we can push this information to the user. So till now, we have predicted that what is your likely time of purchase, and given that, what is the segment that you will purchase. So towards your left, you see a pull module where users land on Flipkart website, and we want to display a personalized module prompting the user to make a purchase, and immediately, like the big basket example which I mentioned on the first slide, we want to prompt an immediate purchase and checkout, so that it maximizes the chance of conversion. Towards your right, we did some in-lab experiments, and we also sent notifications to certain users who had made purchases with us in the FMCG categories, and we saw an uplift of 150% in our conversion rates. So in effect, this repeat purchase has proven to be an important feature in addition to our normal set of personalized recommendations. And if you open Flipkart app, you might be seeing personalized modules, and one of the personalized module can be a replenishment module like this. Yeah. So these are the papers that we referred to. The first one is from the work presented by us in Rexis, and the other two are the ones we referred to. Yeah, and thank you. Now we'll take questions. Yeah.
There's a mic coming your way. There are questions here as well.
I know that you kind of explored FMCG, and you also cited groceries as a potential category. Maybe they are like volume play, but the dollar value may not be much.
Right.
And extrapolating this, can you also comment on applicability to fashion? Probably like maybe the same product may not be bought again, but something different.
Right.
Likely, or maybe even electronics are large.
Yeah.
So new product comes, and I had my washing machine for the last year or two.
Yeah, right.
So how will effective can this be, and will at least the techniques, will they apply, or?
Yeah. So in the first thing, like you said, it's a low volume purchases, and it's like a habit formation for the customers. So customers who purchase like this are likely to be more loyal to you, because they'll be coming to your portal again, and you have a chance of selling them an alternate item as well if you showcase it properly. So if you model the repeat purchase problem properly, like the repeat rate is it's not contributing to your GMV as you mentioned, but there will be a repeat construct, and overall it's beneficial for Flipkart. to mention, add to your Flipkart fashion example. So here again, so the problem which Kratika mentioned here. So fashion products go out of stock very fast, but since this model it at a segment level, so if we can figure out a right segment of fashion products and map every incoming new product to that segment, we can very well predict the next purchase of your fashion. But again, we did some POCs on fashion, and for women's fashion, incidentally, we see a very good repeat rate. On the other hand, men's fashion, at least on the initial data that we saw, men's fashion doesn't tend to replenish. So women's fashion, yes, there is a huge scope of extending
Yes,
this.
we mentioned the first thing, like we did some analysis on categories. So there we figured out that such repeat purchases are not that frequent in case of fashion or electronics. So because electronics mein repeat purchases were happening, but they were mostly because of resellers. And fashion mein, for girls, I don't think there is any kind of replenishment. We just order if there is offer and whenever we like. And for men's, and we can actually so there are not this repeat interval things which affects the fashion, but there are other factors like offer, as we mentioned, and seasonality. All these things can affect it, but yeah, we can actually explore these categories more. But our initial observations, those were not that prominent, so we just went with FMCG categories.
Yeah, hi. So can you shed more light on that limitations page, the first limitation you said about number of repeat purchases should be more? I mean,
yes, so here we are actually learning the model per user. So for that we were, as I mentioned, we are also checking at what frequency user purchases it. So if the user has made only one purchase, at that time we cannot predict its frequency interval. So at least there should be 2 purchases. But if there are 2 purchases, in that case our model will not be that accurate.
so basically here the question is about predicting the periodicity of buying that product, right? So once I have seen enough number of purchases, can I just go with that periodicity? Let's say a product is bought every 60 days. So
Yeah.
can I?
Yeah.
So
So
if-
as we mentioned, one of the baselines, right? So one of the baseline that we took for our analysis was exactly the mean periodicity over your last few months. So we took a mean over the last few windows and tried to predict the next window. So our model is a slight improvement it showed in terms of the standard deviation with the test data. So it did show improvement over the baseline. So if you go, you can refer to this paper for details. If you go to the paper, there are various these baselines, more baselines mentioned, and you can contrast. Like one of the baselines is exactly this. We can directly use the periodicity if we have sufficient number of data points.
So it's essentially just exploration versus exploitation problem, right? You explore enough, and then you start exploiting on your exploration.
Yes, yes. So there is a fine line. Basically, how do you tie the pure explore versus pure exploit, and we are somewhere in the middle.
Yeah. Okay.
Hello. Hello. Yeah, so
And that will be our last question.
yeah, so this question is about the timeline till when we recommend something. Like if we find a user is purchasing every month,
Right.
then do we recommend for 15 days after a month, or we recommend for few days, or what is the limitation there?
That's a good question. Yeah. So in the first slide. So as she mentioned, there was a Webull distribution that we modeled. So it does peak after a certain number of days. So 1 second, I'll just go to that slide. Yeah. So we are just showing the increase in probability here. So there is a probability touching 1. After that, there is these peak. So Webull distribution, based on its parameter, it comes back down. So there is a sweet spot where you want to recommend it. So in this case, for the blue diagram, starting 25th day to say 35th or 40th day, and after that the probability will die down. So there is a sweet spot, and you might continue to recommend it even after then, but the likelihood of conversion will not vary in that proportion.
Done. Thank you so much. Well, other questions, you can connect with them offline. Well, Akash, this is for you. Thank you so much for being part. It was a wonderful day.